Now see this question. There is a recurrence relation given. For the recurrence relation, t of n equal to 2 into t of n minus 1 minus t of n minus 2, n is greater than or equal to 2. So why do you think that n is greater than or equal to 2? Because if you substitute 2 in this, anything less than 2, let us say if you are trying to substitute n equal to 1, then this one will go to 0. Generally, recurrence relations will be defined for non-negative numbers, which means t of minus 1 minus 2, they will not be defined. That is why the border condition is given like this. Now they are asking, find out whether the following are solutions or not. So they are given you the recurrence equation relation, and now we are supposed to find out which one of the following is going to be the solution. So the same way which we have seen earlier, you can find out the left hand side and the right hand side, and you can equate it and you can go ahead with that. Okay. So one way is that, and the other way is if you can directly substitute some numbers and get it, it is fine. But in this case, the base conditions are not given. So what are the base conditions? What is t of 0? What is t of 1? That is not given. But then you can see here, if you have to find out t of 2, you are supposed to have t of 1 and t of 0. Then you can find out t of 2, right? Therefore substitution method is not very straightforward. So instead of that, you can do various things here. Okay, so anyway, I'll tell you the short forms here. So first thing is, let's find out whether this one can be a solution to this one or not. In exam you can try like this. Okay, if this one is going to be a solution for this, it means that all the values t of 0, t of 1, t of 2, everything should be same for both of these, right? So if you can see this, let us say t of 0. T of 0 according to this is 0. What about t of 1 is 3. What about t of 2 is 6, isn't it? What about t of 3 is 9. Now you can verify these numbers from that equation. Now let's try to get t of 2 from that equation. T of 2 equal to 2 into t of 1 minus t of 0. Now what about t of 1? T of 1 is 2 into 3 minus t of 0. T of 0 is 0, which is nothing but 6. Therefore it is verified. What about t of 3? T of 3 is 2 into t of 2 minus t of 1, right? Now what is t of 2? 2 into 6 minus t of 1, which is nothing but you have to substitute 3 here. So what is 2 into 6? 12 minus 3, which is nothing but 9. So it is verified, right? So you can verify few values, then you can say that yes, both are giving the same values, and so it is a solution, right? That is one way. Now this method will be able to eliminate some options, but then this is not the right method to say that this is the actual solution. The reason is, maybe for 0, 1, 2, 3, maybe for this 2 and 3, both the values are same, but later at some point they may vary. Therefore it can be used as a negativity test, which means you can eliminate some options using this, but then you cannot perfectly say that, confidently say that this is the right answer. So for this one you can go with the substitution method as usual, you will get this. So this is method 1. okay, if you can test for generally 3-4 values, if it is true we can assume that it is true, but if you don't want to take any risk, then you try in the second method also. So method 2 is what we discussed already. You substitute in the left hand side and right hand side and you can get the answer. Now in LHS of the recurrence equation, according to this solution is t of n is equal to 3n. Now what about the RHS? RHS is 2 into t of n minus 1. So t of n minus 1 is nothing but 3 into n minus 1 minus t of n minus 2. T of n minus 2 is nothing but 3 into n minus 2. Now this is nothing but 6n minus 6 minus 3n plus 6. So 6 and 6n is going to be cancelled and it is going to be 3n. Yes, both are same, and so using this method you can say that it is the solution, right? Now let's test the next one. T of n equal to 2n. let's try method 1. So generally using this method you will be able to eliminate the option very easily. So since this is a small question, you can directly go with substitution, but then with bigger questions it is better you go with these new numbers. That will be easy. Now according to option B, let us talk about the numbers. Okay, t of 0 is equal to 1, t of 1 is equal to 2, t of 2 is equal to 4, t of 3 is equal to 8, isn't it? Because 2 power 0, 2 power 1, 2 power 2, 2 power 3, right? And now according to the equation, let's talk about t of 2. T of 2 has to be 2 into t of 1 minus t of 0. Now what is 2 into t of 1? It is 2 into 2 minus t of 0 is 1, which is nothing but 3 here. So according to this equation I got t of 2 equal to 3, but then according to the solution I got t of 2 equal to 4, which are not equal, and so you can directly say that they are not right. Got it? So even if you want to check it, the method 2 also, now left hand side is t of n equal to 2 power n, and right hand side is 2 into t of n minus 1 minus t of n minus 2, which is nothing but 2 into 2 power n minus 1 minus 2 power n minus 2, so which is nothing but 2 power n minus 2 power n minus 2. If you pull out 2 power n minus 2 in common, you are going to get 2 square minus 1, which is 3 into 2 power n minus 2. Obviously these two are not equal, therefore it is not the solution. Now let's talk about C. If C is saying that t of 0 equal to 5, t of 1 equal to 5, t of 2 equal to 5, t of 3 equal to 5, everything is equal to 5. Now if you see t of 2 according to that equation, t of 2 is equal to 2 into t of 1 minus t of 0. Now what is 2 into t of 1? 2 into 5 minus 5, so which is 5, right? So yes, both are fine. And what about t of 3? T of 3 equal to 2 into t of 2 minus t of 1, so which is nothing but 2 into 5 minus 5, which is again 5. So even if you substitute it, you are supposed to get it. Okay, now let's try substitution. So in left hand side, t of n is equal to 5, right hand side it is 2 into t of n minus 1 minus t of n minus 2, both are equal to 5, right? Therefore 2 into 5 minus 5, which is nothing but 5. Got it? So that is how this is actually equal to 5. So we can see that this one is a solution as well as this one is also a solution. How can there be two solutions to the same recurrence relation? It is possible because even though the recurrence relation is same, initial conditions are not given, right? So according to this, initial conditions are different, and according to this, initial conditions are different, which means according to this sequence is different, and according to this sequence is different. If you are looking at the sequence for this one, you will get 0, 3, 6, 9, 12, so on. If you look at the sequence for this one, you will get 5, 5, 5, 5, 5, so on. And for both the sequences, the same recurrence relation is applicable, but only thing is the initial values are different. But since the initial values are not same, we got two solutions. Okay. Fine.
Hi, if you are planning to do masters, then doing masters abroad is better than doing masters in India. I'll give you all the reasons. So, first reason is, out of 1 lakh students who take GATE every year, there are only 500 seats in old IITs. So all the IITs put together have an acceptance rate of 0.5%, and IITs, universities better than IITs, they have very good acceptance rate like 30%, 40%, but all the IITs put together have an acceptance rate of 0.5%. And if you are working hard to get into IIT Bombay's ranking is 177 and IIT Roorkee's ranking is 400. If you are happy to get into IIT Roorkee, then getting into universities better than IIT Roorkee is easier compared to getting into IIT Roorkee. And looking at the salaries for computer science, for software jobs, if you have done your masters in computer science in US, the salaries are ranging from 80 lakhs per year to 1.2 crore per year. So even if you take an average of 1 crore per year, your savings will be much higher than the salaries in India. After taxes and your cost of living, you can easily save 40 to 50 lakhs per year. And in India, the maximum jobs that you get is around 30 lakhs. So your savings will be much greater than the salaries in India. And these are all the services that we provide. University shortlisting. So depending on your profile, we will shortlist what are the universities that you have to apply, and statement of purpose building, and then LOR guidance, and GRE and English test assistance, and education loan assistance. So you don't have to have any collateral, which means without any security, now you can get education loan. Getting education loan is very simple these days, and whatever the amount of fee that you have a range of universities. You can apply for 10 lakh universities, 20 lakh universities, or 50 lakh universities. But whatever it is, you are going to get complete education loan, and you can pay off your education loan in 1 year after you get a job. And then we do visa assistance, mock visa interviews, and then connecting with the university alumni. So now you might ask why we should join Game of Visas. So the answer is we have 90% success rate, 99% success rate. And these are all the destinations that we guide the students to. So we guide students to any country that you want to go. So now it is not just USA. We guide to UK, Germany, Australia, Canada. So we guide students to all the countries. We work with all the destinations. And if you are interested in going abroad, you have to just drop us a message on this WhatsApp number 9494 555 454. Okay, thank you.